Physical sciences, modern astronomy.
And this is the part 3 of 3 series. I already made the part 1, the part 2 already finished, and now this is the last part of the series of the modern astronomy. After this, modern astronomy topic is complete. Okay. At the end of the session, one should be able to read, please.
Enumerate Kepler's law of planetary motion and explain Kepler's law of planetary motion.
Okay, great. So this is the $1 billion puzzle already given on the first part of the modern astronomy. The second part, I already did also. And this is the last one. This will become a performance task. Okay. By this time, I surmise that you already have researched the possible solution to the $1 billion puzzle. If with all your effort you still cannot find the answer in the internet, then you can tap anyone who you think can help you solve the problem. Good luck. Okay. Let us start. What's that? Please.
Kepler's law of planetary motion.
Okay.
First law, the law of ellipses.
Okay. By the way, who is Kepler?
Uh, the he discovered the three laws of planetary motion.
Okay, yes, correct. Johannes Kepler discovered the 3 laws of planetary motion. Proceed, please.
When Kepler tried to figure out Mars' orbit, it did not fit the then famous theory that a planet follows a circular path.
Continue,
He then,
please.
he then postulated that instead of a circular path, planets follow an oval or an ellipse orbit.
Aha, this is what Johannes Kepler discovered. When he observed, what did he observe?
That it has an oval or an ellipse orbit.
Yes, correct. So this is the sun. And what is that? The other one?
Earth,
Earth, planet, yes. Okay. And what is that?
the orbit.
That will become the orbit of the Earth around the sun. So that arrow one, that is the movement of the Earth, the revolution of the Earth around the sun. When viewed from the north side of the sun, you will see that the Earth is revolving counterclockwise. However, if you view from the south of the sun, you will see the movement of the Earth moving or revolving clockwise around the sun. Okay? Orbit. Can you please read?
Second law, the law of equal areas. The
Continue
second
reading.
law,
Sorry.
the second law, which is the law of equal areas, states that when an imaginary line is drawn from the center of the sun to the center of a planet, the line will sweep out an equal area of space in equal time intervals.
What do you mean by that?
Wherever part of the orbit, you will have equal areas.
In any, yes, in any part, no? In any position in this elliptical orbit around the sun or around any planet moving, actually, all moving objects in the universe are moving in elliptical orbit as what Kepler found out. Okay, so we will further clarify this. Let us continue. What are you seeing? Again, the planet, the illustration we just showed a while ago. What's that? From A to B, and there is this green. What is this? See, please observe. From A to B, green. Can you please evaluate this illustration? Can you please tell me more?
Uh, the green, the green shaded part. This is the area.
The area.
And even if they have different dimensions, they still have the same area. They still have equal area.
What do you mean by the dimension? From the arc length, right?
Yeah.
From the
Uh,
perimeter of
mm,
the ellipse, right? Even how much longer? You're saying that the area will come up equal with the other side, with any side, right? Is that what you're saying?
yeah. Mm.
Okay. So we go deeper. Okay. So AB at the aphelion, the length of arc is shorter compared to that of the perihelion, which is the length of arc is longer, right? Now, what is the idea for this? Can you please read?
The law describes how fast a planet moves in its orbit. A planet moves fast when it is nearest the sun,
Mm-hmm. Yes, 30.29 kilometer per second. Continue.
and slow when it is farthest from the sun. And still, the same area is swept out by the line in equal amounts of time.
Aha, yes. So that is why, no, when the planet is away from the sun or from the moving object is away from a body being orbited, the the speed is a little bit slower compared to that when you're near to sun, the perihelion. This is to compensate for the same area that can be swept in an equal amount of time. Okay. We go on. Continue reading.
The planet moves fast when it is nearest the sun and slow when it is farthest from the sun. To compensate the equal area the planet must achieve in the realm of the whole surface of an imaginary ellipse at any given point in time.
This is what I'm telling you. When the planet is nearest the sun, the fastest it will go to compensate for the equal area, surface area, we should say. And the farther away, slow down to compensate again for the area. Okay. Let us have a simulation of a planet revolving around the sun. Let us say that time required to travel from point A to point B is 1 hour. We put A and B, huh? Okay. Number two, the area that can be covered by traveling the given arc length A to B, we just assume or put to be 100 square meter, something like this. What can you see? There is this planet, perihelion, aphelion. Please observe this animation. See? Okay. So we have this A and B aphelion, A and B perihelion. The movement of the planet moving. What can you see? Let us repeat. Okay. Once more. Okay. Again, from A, now moving, going to B. See? Aphelion, perihelion. See? There's equal amount of time. Let's say 1 hour. Okay. Uh-huh. Let us start with this one. A and B, aphelion, travel time 1 hour from A to B. Perihelion, travel time 1 hour. You see the distance, perihelion longer, aphelion shorter, because it will sweep an equal amount of area. Let's say 100 square meter. In this case, 100 square meter. So, the Earth during perihelion so fast, just to compensate for the equal area. Not only during aphelion and perihelion, anywhere in that elliptical orbit, inside of that, the movement of the Earth should compensate for an equal area as the Earth is revolving around the Sun. Okay, now let us have a look with this one. Another example. This is not only applicable to aphelion or the perihelion. Let us see the other sectors moving. Okay, see now. Okay. See, there is a movement now. Can you see the movement?
Yeah.
Yeah, all. Let us say you are there in AB down below. Okay, again, we stop for, uh, we rewind a little. See, can you see how many moving
Four.
objects? So, as we go on to the perihelion, you would notice that the length of the arc length is increasing. From aphelion, whose length is short, then going to perihelion, the length is increasing. This is to compensate to get the equal amount of area available in the surface of the ellipse. Okay? See? Again, we try. We start. Okay. Let us see. Now, all the four Earth are moving. They will arrive all in 1 hour. See? Perihelion so fast. All 100 square meter. So that is the classic example of how we can explain the second law. No, the movement of the body depends upon where is the location of it in the orbit. If it is farthest, the speed is slow. When it is nearest the sun, the speed is so fast. So going from perihelion, going to aphelion, the speed is decreasing. And then from aphelion to perihelion, the speed is increasing. Understand? Yes?
Yes. Yep.
Great. Now, can you please read?
Third law. The law of harmonies.
Uh-huh. By that term, what do you mean? By that term alone, what do you mean by that? Harmonies.
Mm.
Law of harmonies. Can you please read?
The law of harmonies, which is the third law, describes that the square of a planet's orbital period T2 is proportional to the cube of a planet's average distance from the Sun, R3. It states that the ratio of the squares of the periods of two planets is equal to the ratio of the cubes of the average distances of these two planets from the Sun, or
And that is the formula. T1 squared over T2 squared equals R1 cube over R3 R2 cube. No? Actually, based on Kepler's observation evaluation, he found out that there is a computation for the planet. Nag-come up siya. Bawat compute niya, nag-e-eksakto sa kinalalabasan kung nasaan yung location nila ng 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 Pluto, ng Jupiter, Pluto, tinanggal na nga pala sa pagkaplaneta yon, ng Saturn, ng Mercury, base sa computation niya. Kaya nag-arrive siya sa law of harmonies, na compute niya, na base sa mga computation niya yon, given distance and the orbital period, na naroon sila sa lugar na iyon, sa posisyon na iyon, base sa mga computation. Now, pag ikinumpit mo, we'll see later on. Where the subscript 1 indicates planet 1 and subscript 2 indicates planet 2. Okay. Let us compute with the given data below. Okay. Let us have a two planet, Earth and Jupiter. The distance, the mean distance of our planet from the Sun is 149,600,000 kilometers, while Jupiter is 778,348,821 kilometers. That is the mean distance. The orbital period of Earth is 1 year or 365 years, while Jupiter, the orbital period is 11.86 years. So naka 11.86 na tayo sa Earth, isang orbital pa lang ng ano yun, isang complete cycle pa lang ng Jupiter around the Sun. No? Okay, let us see, let us prove. No? Okay. Let us prove, can you please read, Ben?
Prove that Earth and Jupiter are in harmony with each other in relation to Sun, and that Earth's orbital period we assume is still unknown.
Okay, suppose that we do not know the orbital period of Earth. Okay? For of course, the orbital period of Earth is 365 days or 1 year, no? We assume we do not know yet. We will compute whether we will arrive in 1 year as the Earth's orbital period. If that is the case, there is really a harmony. Okay? Let us see. So, we put green, X green. We do not know what is X, what is Earth's orbital period. Okay? Can you please read?
Let X is the Earth's orbital period. Find X.
Okay, find X. We do not know the find X, but Earth mean distance given, Jupiter mean distance given, and the orbital period of Jupiter is 11.86. The formula is T1 squared over T2 squared equals R1 cube over R2 cube. Okay, so here we go. X squared, 11.86. Tama ba yung pagkakalagay, please? 149,600,000. Tama, no? Okay. So, kailangan ito ng calculator. Sinortcut ko na yan. Na-compute ko na yan, na-pre-computed ko na. Ganyan kalalabasan pag gumamit ka ng calculator. So, yun. Yan. Ayun ang kinalabasan niya. 4.7 times 10 to the power 26. We are talking of we are looking for the orbital period of Earth. So, anong kalalabasan nito?
1.
1 year. So, what can we conclude then? Can you proceed?
Therefore, Earth and Jupiter are in harmony with each other.
Yes, ayan ang ibig sabihin ni Kepler. Hindi lang yan. Kahit na anong kumpitin mong dalawang planet. Halimbawa, kumpitin mo yung Jupiter o Saturn o Mercury o dalawa o Venus o Mars. Lalabas na ganun lahat sila. May harmony sila. Naintindihan mo? Ha?
Yeah.
Kumuha ka ng dalawa dyan ng mga planeta, kumpitin mo. lalabas na pare-pareho yung mga figure nila. Ibig sabihin, nakalagay sila ngayon dyan sa elliptical orbit nila base, kumbaga, sa tamang kalagyan nila. Mm, tama yung pagkakalagay sa kanila. May mathematical calculation. Nakalagay sila dyan, hindi basta-basta lang. There is a purpose. There is a reason. No? Yon. Nakaayos sila lahat. May mathematical arrangement sila. Hindi sila gulo-gulo. Naintindihan?
Yes.
Ha? And that
Yep.
is the law of harmonies. Kuha ka ng dalawang planeta, mag-compute ka dyan. Lalabas puro tama yung mga figure nila, nagkakasundo sila. Okay. Sabihin mo, Earth, Jupiter, yan. Hindi natin alam ang mean distance ng Earth na 149,000. Alam natin orbital period, 1 year. Lalabas pa rin yung 149,000. O kahit na ano, Mars, Venus, mag-compute ka kata ng dalawa dyan, lalabas, tama pa rin yon. Kumbaga with harmony, ayun ang law of harmony. Okay? Naintindihan?
Yes.
Nakaayos lahat sila. Okay. O, 1 year. Ayan, no? Therefore, Earth and Jupiter are in harmony with each other. Tignan mo yung distribution ng Earth, ng planeta. Unang-una, Mercury. Sunod, Venus. Sunod, Earth. Sunod, Mars. Sumunod, Jupiter, Saturn, Uranus, Neptune. Hindi sila nakalagay dyan accidentally. No? Talagang nakaayos sila. May purpose, nakaplano na nakalagay sila dyan. Hindi sila basta nakalagay dyan na basta-basta lang. Kumbaga, para bang may naglagay ng inayos yan. Ang galing ng pagkakaayos. Why? Later on, we will know. Okay. Reflection on Kepler's law. What can you say about the reflection?
Mm,
Can you please read?
Kepler's law of planetary motion only connotes that the solar system alone is not just randomly existed for no organization and no reason at all. The arrangement of the planets based on its distance to sun, relation of every planet with each other, the positions and movements of every part of the solar system, their respective patterns and mathematical analysis speak well of an intelligence, organization, and the relationship or harmony of the solar system. Jupiter and other giant planets are intentionally in the place where they are right now because one of the reasons is that these giant planets serve as the protectors of the inner small planets, the major absorbers of the meteorites, comets, and other space debris.
Yes, see? Kita mo? Nariyan ng Jupiter. Kaya nga meron tinatawag tayong, alam mo ba yung meteorite shower? Di ba nangyayari yon? Tapos ang tinatamaan lagi Jupiter. Kumbaga sa yung shock absorber. Kung wala ang Jupiter, matagal na tayong na-bombard ng mga comets, kung ano-ano pang mga meteorites. So that is one of the purposes of that. Parang nakaayos lahat, hindi basta-basta. Parang may naglagay, nag-ayos. Parang yung, sabihin mo yung sun, yung nanay. Tapos sabi ngayon ng, anak, o dyan ka, bantay mo mga bunso mo, si Jupiter yung panganay. O dyan ka, bantay mo bunso mong kapatid, ha? Ayan. Something na gano'n, nakaayos lahat. No? Kumbaga, amazing ang pagkakagawa. May mathematical calculations. Bakit magkakaganon yun kung random lang yon? Bakit nakukuha sa mathematical computation? Lahat naka-order, nakaayos. Kumbaga mga silent lang pala sila. Lahat ng narayan, pero nakaayos pala yan. Kita mo sa Fibonacci sequence, di ba? Meron ding ano yon, organization yon, di ba? Lahat nakaayos. No? Maski sa mga DNA natin, nakaayos lahat, di ba? Ganun din sa planeta. Okay? So, go ahead. Naintindihan?
Yeah.
Great. Again. Can you please read?
Kepler hadn't known about gravity when he came up with his three laws. However, Kepler's law of planetary motion was instrumental in Isaac Newton deriving his theory of universal gravitation that explained the unknown force behind Kepler's third law. With the advancement of modern astronomy and science as a whole, still there are enormous phenomena, mysteries, and information to be uncovered and explained.
Okay.
Exploring and understanding every parts and details of the Earth alone has not yet been resolved. The vastness of information the infinite universe has to offer. There are, I guess, immeasurable things to discover and do.
Yes. Any question? Any question?
Mm,
Okay. So, yun
no.
lang yun, ano? Naalaman natin, na-prove natin, base sa pag-aaral natin, na lahat pala nakaayos. Not just randomly being positioned there for nothing. Everything is in the right place at the right time for a valid reason. Okay? Now, tell me, what are the three laws of Kepler's planetary motion?
First law of ellipses.
Okay? Next.
Second law of equal areas.
Okay?
And third law of harmony.
Can you please tell me the three? Explain.
The first law is that planets have an oval or elliptical orbit
Elliptical orbit. Okay? Around the na.
around any celestial body.
Yes, that it's revolving. Not only because uh, it's not only applicable to sun, but any, no? Any celestial body revolving